Right, just go with it.
All right, guys, real quick, there's one thing that is on that sheet I gave you that we actually didn't go over. I want to go over it real quick. It's called a tree diagram. All right, so it's not like oak tree. If I had, let's see, if I was going to buy a car, and let's say I could buy, the car I want only comes in blue or red, right? Blue or red, let's say, right? Somehow this is going to relate to a tree. Yes?
Are we still on chapter 4 or chapter 5?
This is one thing left over from 4, and then we're going to get into chapter 5.
We have chapter 5? Oh no.
Dude!
Yeah.
It's crazy. Andrea, are you okay?
Yeah, I'm just texting
Okay.
my mom. She just said something. Sorry.
All right, you're good. So let's say I'm going to buy a car. It could be blue or red. Choice 1 is blue or red. Choice 2 is interior. So this is exterior color. Interior color could be white, beige, or black. And then I could get, what's another option on a car? I can get a roof rack or not. Roof rack from a kayak. Roof rack from the kayak. Or not. All right. So this is just one more possible visual way to figure out how many total possible cars there are to put together if this is all your choices. So watch this. This is how a tree diagram works. Your first choice is between what and what?
Blue or red.
Blue or red? All right, so you got blue, you got red. Okay. I'm thinking ahead a little bit. By the way, all right, just to make your notes a little better, this is going to get kind of big at the end. So kind of put this in the middle of a piece of paper, blue, red. If I choose blue, what could I choose for the interior?
White, beige.
White, beige, or black? White, beige, black. Are you guys discussing my my choices on colors?
What does number 3 say?
Oh wait.
Who
Yeah.
knows? Roof rack for the kayak, or not? So you can have a roof rack or not.
What does that EXT mean?
Exterior color.
Oh, okay.
Buy or ear? Buy a ear?
Yes, buy an ear. If you need to buy an ear,
I don't know what that says.
right? Either you're tired of yours, or you don't have one, something happened. No. All right. Buy an automobile. E with an extra thing. And then so this is my first choice, second choice, and then if I get a white interior, what can I do after that?
Roof rack.
Roof rack or not? So roof rack, not roof rack. Roof rack, not roof rack. Roof rack, no. And then of course, so off of every branch, so if I go blue for the first option, I still have 3 more. If I go white, I still have 2 more, and it happens for each branch. Has anyone ever seen something like this before?
Yes.
I'm almost certain you all have it to some degree.
No.
If you've never seen it, does this make sense?
Sort of.
Sort of. Okay, so if you choose blue,
Mhm.
what could you choose next?
White.
White, beige, or black? If you choose red, couldn't you still choose white, beige, or black for the interior? I like
Yes.
it. And then, no matter what interior color you chose, you get roof rack or not. 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 Holy shit. So how many total possible combination cars are there? Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Which makes sense because there were 2 options. And for every 2 options, there were 3 more options. 2 times 3 times 2. 12. So maybe? So this is 2 options, 3 options, two options. 2 times 3 times 2 is 12, and you can see each of the 12. So what's this? This would be red with beige interior without a roof rack, right? Colonel Mustard in the conservatory.
The lead pipe.
There it is. Okay, thank you. So you could do that too. You could do it for the Clue game or the Clue movie. If you ever saw the Clue movie, it's awesome. Anyway, so that's tree diagram. Very straightforward. Most people have sort of seen something like this. It's another visualization of multiplication. And this is used a lot in probability studies. Okay. All right, I like it. All right, so that's the one thing out of there that I didn't do. And what I want to do today is I want to first show you some videos. Off of those videos, we'll go into some topics, and then we'll see what the hell goes after that. And we're going to sit here for a little bit right now. What have you guys been doing? Does anyone? Is that slow? Do I have to do it slowly? Ah, okay. Okay, how much time is left? All right.
I think we can go over the homework problems for chapter 4.
Of course.
We
Yeah.
have time.
What do you got?
I was working on it on the 4.1 set A, and question. I think it was. Well, 5F.
4185.
Yeah.
Okay. All right. So this one here, right?
Yeah.
All right. So I mean, all right. Let's take a smaller example. How would you do 200 times 30? How would you do 200 times 30 easily in your head?
20 times
3.
20 times 3.
And then
All right.
6, and then add the zeros.
I asked for that, I guess. Right. 2 times 3, 6. And then count is not 2. 300, what was it, 20? What did I say? 200 times 30. 2 times 3 is 6. 1, 2, 3 zeros. Stay with me now. Does that make sense? Right? Because every 0 is a 10. Every time you multiply 10 by itself, it becomes another 0. Right? So that's all you have to do here. How would you multiply 17 million times 6?
What I did was 17 times 6,
Sure.
and then I got 102, and then I added as many zeros. For example,
Yeah.
and what I got was
How many
One.
zeros do you need? 3,
6,
6, 9,
9,
12,
12.
15. Yeah,
15.
you're right. That's exactly what you do. And that's exactly why, because every 0 represents a multiplication by 10. And every time you multiply by 10, you pick up another 0. So that's the beautiful thing about multiplying very round numbers. Right? Those are both very round. Very big, but it doesn't matter.
Does it matter when we write it the long way, or do you want us to write the short way? Because in the
Scientific notation, you mean?
Yeah.
Oh, it didn't say either way, did it? It just said calculate mentally. To be really honest, I would take it either way. Shit. If you want to put it scientific notation, it's beautiful. Although sometimes it means you got it out of your calculator, which is bad. You know, this one says do it mentally. Yes.
Also, I was in 15A. It said estimate the following values and check with a calculator. Now I tried to do what I did for number 5, but then I was kind of.
Well, you definitely can't do what you did for number 5. You have to turn this classroom. Nobody knows that. You have to turn this far. So you can't do the same thing you did for number 5 because these are not round at all, right? So this is estimation. I don't want an exact answer.
What I did for estimation was 600 times 70, and I got
Sure.
42000, which is, I guess I could say 42,000.
Sure.
But then I tried.
And that's the lower, right? Why is that the lower estimate?
That's the lower.
Because you took each one of these and you took them down.
I took them down by
Now to
zero.
get the upper estimate, you take each one and you take them
Up.
up.
So how about I would take it up exactly?
Well, you took this as 600 and you took this to 70, now take this to 700 and take this to
80?
80. I
Big-
like it. Now, what's the better way than either one of those to really estimate and get close? If you take one number up, you should take the other number down, because then the multiplication would kind of average out. I like it. We talked a little bit about that before. This is just asking for an upper or lower bound. Is that cool?
That is cool. I
Okay.
just wanted to be sure if it's like if I do exactly what the book says, because I don't wanted to get it wrong, because for 15 it said 42 and 56.
1,000, yeah, because the 1,000's already there, right? See?
Yes.
They already put the 1,000 up there.
Oh.
The 000.
But then
Yeah.
how would you do for C?
Alright, so isn't 143 squared, what does that mean?
You multiply twice?
143 times 143, and then it's a problem just like these. If you just write it like 143 times 143, it's exactly a problem like those. Does that make sense?
That
Yeah,
makes
So the
sense.
square doesn't really mean anything, I just have to write what that means, and then you can do the exact same thing.
So
Okay.
I can do 140 times
Well,
1.
you can go even better than that. Just the way you did 670, right?
Mhm.
You could do 100 times 100 to go down, and then the other way to go up, to get the upper bound. Exactly the same way.
So 143 would be 150. Would that be going up?
Yeah, but they want you to go even more than that. They want you to go extreme, to make it as round. What's 143? 100. They can round it down to 100, so 100 times 100. What if I round it up? We round up to 200. So they want you to just take this sucker and don't even try to round it well. Just round it straight to the most round number. Is that cool?
So that would be, okay, so 100 times 100 would be 1,000. And you said I have to go up, you said?
Well, 100 times 10 is 1,000.
Yeah.
But you just write the numbers out and write the number of zeros you need.
Yeah, but like what?
Now listen,
how do
Andrea, I
round it
really
up?
want you to get this. You took this to 600 and you took that to 7.
Yes,
right?
I did.
And then we took it to 700 and we took that to 80. Right? So 143 times 143, what do you take it to 100 and 100? Okay. And you just write 1 and you follow it with the number of zeros you need, right? The same way you did before.
Uh-huh.
And then you would take it up to 200.
The 200, so
And if you write it out, you can count the number of zeros you need.
200 times 200 would be,
Now that one you should be able to do in your head. But that's all.
that'd be 4,000.
How many zeros?
1, 2, 3, 4.
4 zeros. And 1,000 has 3 zeros.
So it'd be 1 and 4.
It'd be 40,000.
So it'd be 40,000 because of all those zeros right there.
Yes. You gotta have all the zeros in there. I like it. Anybody else? Questions? Yes.
I have a question in section 3.28. And it's 24B.
Oh, yeah. I mean, listen, sorry, I'm laughing because I'm imagining
Is it 24B?
me as a student in my own class. Because look at the question. Isn't this 24B?
Yes.
This one? Can you make a multiplicative magic square?
I'm gonna do it.
And you try, can you just say no? I mean, couldn't that be the right answer? Anyway, sorry, it's my own personal little thing. It's possible the answer is no. Because, I mean, that's really, just to make it not a joke, it's possible the answer is no, that it's not possible. The numbers 1 through 9 will not work in this case. So they're saying you could make one, but it can't be 1 through 9, it would be something else. This one is very big, I'll give you that. So, I'm just gonna leave that one open. If you can't do it, it's not the end of the world. Just give me some ideas of what you tried, and then I can kind of give you some notes from there. Yeah. Yep.
3.2 step B, number 35.
More Maurice, alright. Some people call me Maurice. Okay. Oh yeah, oh this happens more often than you even realize. Holy shit. It's always something with this thing. Alright. You don't like working. So rewrite 6 times 7 times 3 as 6 times 7 times 6 times 3 says that he used distributivity. So what is the distributive property? It's of something across something. Give me a normal distribution problem. Give me something that you would use distribution for. Give me a problem you would use distribution for.
X times 2, and then on the outside would be like a 5. Like 5 parentheses X times plus 2.
There it is. Okay, there it is. So it's multiplication across addition, right? Are you guys? Right. So it does not work across multiplication because the whole thing that distributive property is built on is this is repeated additions, and this is not addition, right? So I can't the distributive property won't work here. I remember, why does, let me get some paper. Why does distributive property work? Could anybody show me? Here, let's make a nice easy example. I know. Go ahead. Why are you allowed to distribute the 2? Isn't that going against the order of operations? Right. Won't something like the TVA come and get you and prune you and shit if you do that? I don't know. I kind of want that to happen. I want to see the mathematical alligator. But I'm totally, right? Isn't this 2x plus 10? Isn't that what that is? Yes?
Yes.
Do you guys remember why we're allowed to break the incredible order operations that we have a little saying
I
for?
don't know the property, but why ever.
Okay, remind me what this means. What is the fundamental way to address what that means? What is multiplication that is most fundamental? No, that's x squared. I think you said times, right? Multiplication is repeated addition, so what's 2x? X plus x. I like it, right. So can't I, using the understanding of what multiplication itself is, I can rewrite this as addition. Do you understand how now I'm at a different level of order operations? Multiplication is in one place, addition is in a different place, because I rewrote the problem using a more fundamental understanding. Okay. So pretty cool. So, how can I rewrite this? What do I have 2 of?
X plus 5.
X plus 5. So I have 2 x plus 5s doing what to each other? No. What does multiplication mean? Repeated addition. So that is why distribution will not work across multiplication, right? Because you can't, so for example, so what's the actual problem? It's 6 times 7 times 3, right? Where'd you go? Yeah. All right. What would this really mean then? This would really mean 7 times 3 plus 7 times 3 plus 7 times 3 plus 7 times 3 plus 7 times, how many is that? 1, 2, 3, 4, 5, 6. There we go. Good. You guys understand what I just did?
Yeah.
Even if you can't read it? I'm sorry. I'm making a point about a concept I sometimes forget to write correctly. That's what that means. And that is not the same thing as 6 times 7, no. I can't do that. So 6 times 7 times 3 is just 42 times 3, blah, 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 right? Isn't that how I do that? If I do 6 times 7 times 3 equals 6 times 7 times 6 times 3, where the hell did the extra 6 come from? I only had 1 6, right? So that's one way to say it to the to the one who made this mistake is to say, you got an extra 6 there. You got one more 6 than you did originally. So that's where you can start. That doesn't explain why it doesn't work. Then you go back to why distribution works. It's got to be addition for it to work fully. Is that? Yes?
Yeah, I have another question.
Okay. Go for it. I don't hear anybody.
It's 3.3 set B 8E. A lot of numbers and letters.
Oh, wait. Was that the right place just then?
I don't know.
What problem do you?
Because I always forget that this beautiful book,
Ah.
this is section 3.3 and they call
Yeah.
it 3.2. So did
That's correct.
did I just answer the correct question?
Yeah, you
I did.
Yeah.
Okay, so now the question is from where?
3.3
3.3.
set B.
Set B.
number 8E.
8E. Okay, this is like lawyer speak. Subsection F.
E and F really,
The
but
party in the first part.
I'm just, I don't know where to begin.
Oh,
Actually, for F, I don't know how to deal with the exponents because they have different bases.
all right. Now here's the cool thing. All right, you ready? Calm down, Jeff. It's not that cool. 9. What does it say? 9 to the 5th. Oh shit! I gotta break out my glasses down. fast.
3 to the 7th times.
I know. I don't care about all that crap. I'm just gonna pull the 9 to the 5th out. Right? And why am I allowed to do it? Because I can do whatever the shit I want to as long when I'm exploring a problem, correct? I'm just gonna pull the 9. What really sucks about this, what would make this problem so much easier is if all the bases were
The same.
the same, stupid bases,
They're
but
all divided by.
they're all based on 3 already. So what is 9? 3 what?
3.
3 to the second power. So how do I rewrite 9 to the 5th power? 3 to the,
Wait.
sorry. So 9 is 3 squared, right?
Yes.
And there's still a 5 power out there, yes?
Yes.
What do I do with the powers in this case?
Add.
No.
Divide.
No.
What? Multiply. Oh.
May, watch this, watch. 5th power means that many of these things multiply. 5 groups of 2 3s.
So multiply.
Isn't that multiplication?
Yes.
All right. 5 groups of 2 3s is 10 3s. So can't you do the same thing with the 27 piece?
Yeah.
Then won't you have a string of like bases and that's easy as shit? Okay, I like it. By the way, when you're teaching the little ones, don't say easy as shit. It's probably good. Don't do everything correct. But I love that you noticed the numbers are nice in a certain way. They all interact with each other nicely. They're all based on 3, which means there's a way to rewrite it. So it's going to be 3 to some big ass number. All right. Anything else from homework? Yes.
For 15B, I did the
Wait,
lower.
what section?
4.1A, 15B. You see, I did the lower part, but then the higher part in the answer it says 20. Well, I
Yeah,
already understood.
So
But
what'd you do in the first place? You took this to,
I took it to 400 times 3,100.
and then what'd you do for the second part?
The second part I did 500 times 4,000.
Good.
But
What's 5 times 4?
well, 5 times 4 is 20.
Huh?
Oh, 200. Sorry.
Oh, no, now you gotta count the zeros, but remember this problem, when you're checking this problem in the back of the book, it's 20 with these zeros after it, right? Which
There's
is a little bit freaky because this is not even like a full 1,000 or million or something.
because what I got in the calculator was this, which was 6 zeros.
Yeah.
Yeah,
So if
that's
you,
what freaked me out.
how many zeros are here already?
5.
5. So wouldn't there be 2 0?
Yes.
So that's why they put 20 in the back.
1, 2, 3, 4, 5. Oh, okay, yeah. That was
I don't like the way they put that problem together, but cool, because it does trip you up with the zero situation. Okay, I like. Anything else, guys? Yes.
3.3 set B, number 14.
See B. This guy. For each of the following, show that the expression is not equal to the, oh yeah, so show that this don't equal that, right? and insert parentheses so it will equal that. Those are some of the weirder problems. I love it. I mean, do you understand the idea? Like, for example, I'm going to show you. I could accidentally do this the way it's supposed to be. So obviously, the first step is easy. Yes, you just kind of do it. 22 minus 14 minus 3 is not 137. But for example, I could put parentheses like here. Do you see how it's the same problem? I just put parentheses in. So doesn't this mean 22 times? Don't tell me I actually did it, did I? No. No, that doesn't work. Okay. Do you understand? Do you get what the, because now, how else could you put parentheses? Couldn't you put them around the 7 and the 3? I mean, could you?
Oh.
Yes. Will it work? I don't know, I gotta check it. Or did you understand that level and you just haven't found it yet?
Yeah.
Oh, okay, well, if you know what to do and you don't ever get there, just show me your attempts.
Okay.
Yeah.
How did I calculate that? It said for 24, 4.1a, it said 1,233 equals 12 squared plus 33 squared.
Wait a
And
minute. 4.1, A number who?
20.
Did I get that? This year? Wait.
Yeah, that one.
Okay, 1233 equals that. It's just a weird coincidence. What's up? 8833 equals that. It's just a weird coincidence, right? You can try a few other problems out and notice it doesn't work for any problem, any number. How about that? So, well, how did they get this? They took the first 2 digits squared plus the last 2 digits squared, right? So how do you think, so here they give you a little hint for this guy. Think 5882353. So this is where, all right, this is the problem that I can agree with you with, that I don't appreciate, that the examples they gave me don't match with the things they asked. These are both 4-digit numbers, yes? I can split it in half, and that makes sense. Then they immediately gave me a 5-digit number, right? And this is a 7-digit number, right? So they tell you how to kind of split this up. Try 588, so try 588 squared plus 2353 squared and see if it equals this.
Let me see.
And then you got to figure out how can you break up the 10,100. Maybe it's definitely not 101 and 00, or maybe it is.
Let me see that really quick. 580.
Okay. I think that's pretty good there.
2, 5, 3, and squared. What I got that. It
Okay.
says 5882353. So that theory was right.
Okay.
So I have to try to 10,000.
There it is. It's coming up later. All right, so let's watch some kids.
That's great.
See if we see some of our favorites. You guys have any favorite kids?
That one, smart one.
The little dude?
Yeah, that was good.
Little dude's funny, I like him. YouTube hasn't copyright struck me yet for recording this.
Let's go.
Huh? All right, here we go. Let's see, which one do I want to show you? Yeah, all right, let's start with this one. I didn't even check this sound.
All right, what we're gonna do now is, I don't know if that's exactly 24, we wanna get 24 tiles, and I want you to build one rectangle out of 24, build a rectangle out of those 24 tiles. So tell me a little bit about how you're building that. You built this side and then you built this side. What were you doing?
Well, it's kind of like an array because I know that 3 times 8 equals 24. So if I put 3 down and 8 across, then it should even, like each like it would eventually fill in once I put all the tiles there.
Sure.
Yeah.
Okay, so,
Real quick, how would you have improved what he was just trying to do? Kind of gave him away where I stopped it, but what was one mistake he made that might mess up the connection?
Wait. Say that again, so,
What was a mistake that he made that could disrupt the connection, especially if that is, this girl obviously kind of knows what she's talking about, right? Which I think is sort of, some of them have some differing levels of understanding. But we should really see some more students that have some trouble with some of these things. But what's one thing he did incorrectly that could lose the connection between this visualization and what 3 times 8 is?
See it again.
um,
See it again.
Yeah. It's actually, it just happened, and let me, here, listen to what he says at the beginning.
oh,
all right, what we're gonna do now is, I don't know if that's exactly 24.
You should have counted them before you gave
Yeah,
them.
should have counted the damn things. Because if you start putting them together, you assume that they're 24 and you're like one short, the kid might take that wrong. They might think, oh, 24 is not 3 times 8. So, all right, I know this is not a huge deal, but if you're gonna show a student this, you have to start with the right number of tiles or else the connection's lost, right? Okay. So yeah, I have some disagreements with the way.
you'll screw that guy.
I'm not ready to see that,
Oh.
but, yeah.
We wanna get 24 tiles.
But you know that 3 times.
Alright, there's what he gave us.
Okay, so there's one example. Now, how many different rectangles like this can you build with 24 tiles?
Okay, see what?
Sure.
So,
Can you explain a little bit what you're doing there?
well, it's kind of like the factors of 24,
Okay,
like what makes up 24, so I could do another array of 12 and 2.
okay.
And I could do, like I did there, 3 and 8 and 4 and 6. But then 5 doesn't go in 6. But you could do 6 by 4. And then you could do 6.
So how is 4 by 6 and 6 by 4, are they different rectangles?
Well, they're just basically turned.
They'd just be turned.
Mhm.
So if we count them like this and the turned one is the same, how many different rectangles?
Real quick, what property is that? Rectangles, if you turn it this way, turn it around, the area is the same.
So,
When we change
Like
Commutative, 11, individuals
commutative?
commute. What associates? Parentheses associate. Parentheses, when they move, that's associativity. Individuals commute.
Can you remind me what distributive means again?
Yeah, that's the whole thing we were talking about a minute ago, where it's when you multiply in front of a addition, and then you can just multiply it into both pieces. Right, like the 2x plus 10 thing we were just talking about a minute ago. Okay, now. How many times can I interrupt him? I think there was.
So like not including during that?
Yeah, don't include turning.
You could make 1, 2, 3, 4.
4 different rectangles. Okay, great, thank you.
Alright, I think this next one, let's see who this guy is. It's a little confusing. Maybe not. Okay. This is basically the same question, right? Just less, not visually to begin with.
And it's a fourth grader that gives us.
Could you please write down all the factors of 6? Remember what factors are?
What you can time them by?
What numbers, when you multiply them together, would give you 6? Those all of them?
Yeah.
Okay, so those are 4 different numbers, 1,
6, 3, and 2, is that right?
Mhm.
Okay, I'm gonna put some commas in between so we can see that they're separate numbers. Okay, now I would like you to list all of the factors of 24.
Opened.
So how'd you, is that all? Tell me a little bit about how you figured out the ones you got.
Because 1 times 24 is 24. 2 times 12 is 24. And 3 times 8 is 24. And 4 times 6 is 24.
Okay, so how do you know like 5 is not a factor of 24?
It's uneven.
Okay, what about 10? How do you know it's not a factor of 24?
Because if you times it by 2, you go 20. And if you times it by 3, you go 30.
I love that right there, right? Why is 10 not a factor of 24? Because 10 times 2 is 20, 10 times 3 is 30. There ain't no damn way you're gonna make it multiply by a whole number because they're just trying the possibilities, yes.
Did he write 21?
No, he wrote 24, just, I can't.
I thought did he write 12?
I can't
Yeah,
tell
I
you.
can't
He
tell.
did, he caught it at the end. So how did he catch his 12? What do you think he was doing? Because he wrote 1, 2, 3, 4, 6, then the 8 was from the 3. And then he went 24 and he went, oh shit, I didn't put the 2 part, right? So when he was looking back through his list, he saw the 2 was alone. It didn't have its other factor. Is that, I'm sure if you had to make a list of factors of something, do you do it that way? 2 goes into 60, so of course then you immediately write 30 down because you already got those 2 together. Okay.
Ah, so 10 wouldn't work either. What about like 18? How do you know that's not a factor of 24?
It's 18 times 2 big and 18 times 1 is 18.
Okay, all right, very good, thank you.
That's pretty cool. All right. Let's do prime number.
Okay, do you know what prime number is? You've heard of that before?
Yeah.
So, what is a prime number?
A prime number is a number that 1 and itself can only go into.
Okay, so can you write down a few prime numbers that you know? Okay, there's a couple of prime numbers. So,
Yeah, the camera work leaves a lot to be desired. That's all right. I have no idea. It looks like she wrote 13 and
17?
maybe? Yeah.
if I asked you, is 39 prime? How could you figure out whether or not 39 is prime? What would you have to do?
Well, you could divide 39, let's see, 39 by like any number, and if it, like 39 divided by 2, and if it comes out evenly, then like, you know that it's prime because, wait, let's see. That doesn't go in evenly because then you would have 2 19s left over.
Okay,
And so it's prime because, like I said earlier, it can only go in itself and 1.
okay. But you only checked 2. Is that all you have to check to know whether or not it's prime?
Well, no, because you could do, let's see. You could do 3. Oh, it's not prime because they checked 3 and it's 13.
So what do we know about 39 then?
It's not prime.
It's not prime, but why do you know it's not prime?
Because 3 can also go into it, and if 3 can and 1 can, then it's not prime.
Okay.
You guys remember how you check to see if a number is divisible by 3? What we talked about before?
Is it 9?
You add them up.
Add up the digits, yeah.
If the digits you add up are multiple,
There it is. If you add up all the digits in the number and the answer you get is divisible by 3, then the whole thing is. So 3 plus 9 is 12, which is divisible by 3. so you know it's divisible by 3.
I just figured 9 is divisible by 3, but I guess that won't work in every case.
Oh, the other way to look at it is 39 is 3 and 9. So it's very obvious that that's divisible by 3. Yeah, okay. Let's do this. Let me change things up. Okay, our video. Go with you guys. We're going back to you. Okay. So the sieve of Eratosthenes. Dude! Has anyone ever heard of that shit? Okay. If I asked you for a prime number, you could probably give me one, yes?
7.
You can steal the ones that she wrote down. 7 is a good one. I like 7. Is 2 a prime?
Wait,
No.
no.
Yes, 2 is a prime. 2 is definitely a prime. What about 1?
Yes.
Nope. Officially, it's not either. So what is the opposite of prime?
It's one more.
Composite. Stay with me. I love you guys. You guys are all slumping down now. You're all in movie mode. You're like, give me some popcorn. All right, guys. 1 is called a unit number. It's a weirdo. It's a prime number is supposed to be the number and 1, and 1 is 1 and 1. It doesn't fit the definition. So 1 is considered not a prime number. It's a unit number. So notice how 1 is not even on here. This what does this mean? Do you guys know? Sieve, I think, is a program sieve. It's a thing to strain something with. Sieve, so that only certain things come out the other side, so it catches all the big stuff. It's like a colander for your spaghetti. So now watch what's going to happen. 2 is prime. What about 4? Is 4 prime? Screw 4. 4 is 2 times 2. Oops. Right? Any multiple of 2 then, will it be prime? No. Any multiple of a prime number is automatically not prime. Yes? Is 15 prime? No, because it's 3 times 5 in addition to 1 times 15. I really want you guys to do this. So any multiple of any prime number is automatically not prime. So the whole idea of this guy is, the minute you know 2 is prime, so yeah, real quick, prime numbers in red, composite numbers in green. So the minute you know 2 is prime, you know that all the multiples of 2 are composite, because they're all 2 and something. So then if I go to 3, same thing. All the multiples of 3 are now composite. Are you guys with me? No? If I do 5, it's going to go through and do all the multiples of 5. Bam! Do 7. Is there anybody for 7? There you go. There's 77. Yay! 11. 13. 17. At some point, we're basically done. It's not going to catch any more up to 100, right? Now, it could show up to 200, and we could go nice and crazy. Dude. All right, anyway. Do any of you know how big the study of prime numbers is? And I know you guys look at me and you're like, this guy's a total math geek, whatever the shit, why would I give a shit about it? But do any of you guys know anything about prime numbers and how big it is to find the next biggest one? That is like a huge deal. You guys know that? Okay. Do you guys understand? Does that strike you as surprising?
No.
You're like, that's what math people do. They sit around, it's prime! All right.
What is the biggest prime number though that we found?
Look at you. It's almost like I told you to say that shit. All right, so right now, the biggest prime was discovered back in December 2018. I want this to make sense. Real quick, by the way, before we do that, does it make sense that any even number is not prime except for 2, yes? So if you with me? So if I'm thinking of candidates for possible primes, I'm obviously not going to do any even numbers, yes? Because they're automatically not even a candidate. So would it kind of make sense to do an even number minus 1? Isn't that guaranteed to not be even?
Yeah.
Okay. So there's a certain category, oh, I love it, you guys, I've totally lost you, Miss Yarl. So there's a certain category prime number called Mersenne primes, which is something like 2 to the nth minus 1. What's 2 cubed? What's 2 to the third power? 8. What's 8? What's that minus 1?
7.
Is that prime? Yes. But what's 2 to the fourth power?
Wait.
16. What's that minus 1?
15.
Is 15 prime? No. So they're not all prime, but they are good candidates to check. So if you were a math geek without a life, who just wanted to sit there and test numbers for primes, what would be a good place to start testing would be 2 to some power minus 1. Because then it's a possible candidate. It's not even, is it? Even ones are easy ones to throw out. So the biggest one we found is 2 to this power, what is that, 82,598,933 power minus 1. That's the current biggest prime number that we know. So I love that question. That was perfect. Right? You look very amused. Are you doing okay? Okay. All right. Anyway. So this is, there's actually a computer program back in the day when we had screensavers. Does anyone still have a screensaver?
The lock screen?
The one, huh? The lock screen, sure, lock screen. Used to be flying toasters back in the day. So whenever you had a desktop, it would have a screensaver. So I had 2 screensavers on my various computers at home and at work. Way back in the day, I had the GIMPs, which is a search for, it sounds totally different, but it's a search for the largest prime number. So it would use your computer to compute possible prime numbers. And if your computer found a prime number, you could get money. So I'm like, what was I? I was like 17, 18 or something. Like, you can use my freaking computer? Give me some money, please. So that was fine. You didn't have to do shit. And then there was a chance I could get a lot of money. And then the other one was, well, I don't believe in, well, screw it. It was the search for extraterrestrial intelligence, where they were analyzing signals from outer space and breaking them down into their components. It had a really cool looking screen thing where it was analyzing the frequencies of shit. Anyway. So that's beautiful. That was that awesome question. So of course there's a whole page devoted to prime numbers. There's a little more information about it. They think it's the 51st Mersenne prime, but they haven't checked to make sure that the other 50 are all actual primes. So anyway, just in case you were curious. Let me see what else I want to show you here. Real quick, this is kind of nifty. Let's see. What's some good numbers, Jeff? Let's do 60 and what, Jeff? Let's do 60 and 55. Freaky. All right, so what's it going to do? It's going to help me create a prime factor tree. Remember making those things? It's not going to look like that, but oh. So somebody give me any factor of 60.
10.
Holy shit. Somebody else give me a factor of 55.
11.
I like that. So now look here. This was done. Yes, of course. 5 and 11 are both prime, so I know I'm done. This one, I can break some stuff down. Factor of 10, let's say 2. Factor of 6, let's say 3. All right, now. Okay. You guys remember doing this kind of thing? You would actually make a little tree.
No,
to do this?
I remember
that?
that.
Like a table.
Now watch this. Okay. All right. Again, I personally look at this as the DNA of the number. What is DNA? Isn't it the smallest component that kind of makes up who we are, what color our eyes are, all that kind of stuff, right? So when I break it up into its prime components, that's like the DNA of the number. 2 2s, 1 3, and 1 5 can only make a 60. They can't make something else. Yes? If I took your DNA, it can only make you. It can't make something else. And then this guy's DNA is a little less interesting, but oh. And then they got one more thing they want to show. What's the common factor, of course, between these two? 5. So they're going to give me, oh, look at this shit. Oh, shit. Little Venn diagram. So I'm going to put the common factor in there, and they're going to come, oh, look at that. Oh, sorry. with the unique factors in there. Kabam. Now, does anyone remember what GCF means? Greatest common factor. And what's that going to be?
5.
5. It's the biggest number they both share. Now, what's LCM? Least common multiple, also known as least common denominator. I love it.
Oh, I didn't know that was the same.
Yeah, so we just call it a least common denominator when they're in the denominator. It's the same idea. What's the smallest number they both multiply up to be? So if I just do 60 times 55, why is that not the smallest number they could have multiplied to be?
That's great.
True, but why? So now listen, guys. Do you remember doing fractions? I know we're not to fractions yet. Finding the least common denominators.
Mhm.
Yes. So if you had 1/2 and 1/3, the least common denominator was 2 times 3. It's easy as shit. But if it was 2 and 20, it's not 2 times 20. That's wasteful. That's too big. Yes. I love you guys so much. Okay. So here's what's really cool. If you did 60 times 55 and then divided by 5, because didn't you use one extra 5 than you needed? Because don't they both already have a 5? So if you just do 60 times 11, because 60 already has a 5 in it. So to find the LCM, you just got to do this times this times 1 5. So really just do this, and this. You only need 1 5, not 2 5s, because you already have a 5 in both. I love you guys so much. We'll talk more about that when we get to factors. I'll show you a really cool way to do fractions. Okay. Try to read your eyeballs, and some of your eyeballs are like eternally questioning. Yes.
I got the same answer when I multiplied them to 1655 and then divided it by 5.
Yes.
Is that the same? That
Yes.
works for every time?
All right. So I really want this to make sense. Doesn't 60 have a 5 in it?
Yes.
Doesn't 55 have a 5 in it?
Yes.
So you don't need an extra 5.
Well, no, I was asking if, because when I also multiplied 2 times 3 times 5 times, 2 times 3 times 2 times 5 times 11, I also got the same answer.
Of course you did.
That works every time.
Because dividing by 5 left you with the 1 5.
Okay.
Yes. So if you only multiply 1 5 in the first place, you're good. Or if you multiply them together and then divide the 5 out, you're good. You're left with that 1 5. All right, again, we'll come back to that when we're talking about LCD. Sounds a little funkadelic, understood. Yeah, that was it. Okay. This is a little weird. You guys, anybody ever seen that? Not Lethal Weapon. Die Hard. There it is. Back in the day when it was good. They might have been Die Hard 2 when they had the jugs of water and they had to figure out how to get a certain amount. Do you guys not remember that?
Was it Die Hard with the one with the buildings and the guy that was barefoot?
I love that. I'm sorry. I love this so much. Was it the one with the buildings? I love that one. There were buildings.
My parents are huge fans of that movie. I think mostly my dad.
All right, we're not going to do this. That might take us long. Okay. Enough of that. Oh, now you're not. All right. I thought it wasn't going to go up now. All right. Now. So chapter 5 obviously is somehow about factors of numbers. Right. It's also about prime and composite, those kind of go together. So, for example, here's the traditional way you would see the prime factor tree. If I had 68, how would you create this prime factor tree?
Chapter 5.
Yeah, this is 501. What would you start with? There's actually a couple different answers here possible.
2 times 30. Well, actually, no. 2 times 34.
Beautiful. Not a bad idea. It's even, so you can always pull a 2 out if it's even. So that's a prime number, right?
Mm-hmm.
34, of course, is even. So what comes out of it? It's even.
17 and 2.
Take another 2 out because it's still even. Well, think you said it. Did you say it already?
17.
Yes.
7.
Pretty sure somebody said it. So
It
the-
was hard.
The DNA of this number is 2 times 2 times 17, which you could write as 2 squared times 17. Okay. So that's exceptionally old news, I know. But just to remind everybody, that's what it looks like normally. So here's something kind of new, I think. 2 things. Well, first off, this is called, the fact that there's only one way for each number to be broken down is called the fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Okay, there's also something called the fundamental theorem of algebra, which we won't talk about at the moment. But this is the fundamental theorem of arithmetic, and I call it, it's related to the DNA of the number. What was that?
I wrote theory instead of theorem.
I like it. And then we got this idea, okay. Let me set my phone up. I think I completely, okay, that's right, I did. Ship. Fundamental theorem of arithmetic. So what does it mean? Now, real quick, what does it mean? All right, does 4 divide 100? There's a weird way to say it, but does 4 divide 100? So the idea there is does 4 go into 100, right? So yes, 4 divides 100. So one way to write that quickly, well, one choice of notation for that is to say 4 divides 100. Another way to say this is 4 is a divisor. Good Lord, you are really, you want to be heard, okay. Is a divisor of 100. So a little line there, be careful, this is not part of the little line there means is a divisor of. Okay. And of course, 4 goes in 100 how many times? 25. So if a number divides another number, if a number is a divisor of another number. So for example, I love you guys. If A divides B, what does that mean?
A goes into B evenly.
Sure. How can you say that more succinctly? 4 divides 12 because why?
3.
3. 4 times 3 is 12. 4 divides 20 because 4 times 5 is 20. So if A divides B, that means A times something is B,
N.
yes?
Yes.
Oh crap, you're not much better. I like what you said. I think you said, yeah. We can use M or N. A times some whole number is B. Okay, I love it. I love it. Now. And I really want that to make sense because what's one of the first ways you learn the things that 3 divide into? What do you learn right before you start talking about 3 dividing into something? What do you think? Your multiples of 3, right? 3, 6, 9. If you could say 3, 6, 9, 12, 15, you are collecting everything 3 divides into evenly, right? And 3 is 3 times 1, 6 is 3 times 2. So for example, one way to use this is what happens if, oh, where's my good example? Yeah, okay, I like it. If A divides M and A divides N, then does A divide M plus N? do you think? All right, let's test it out, right? That is exceptionally weird to look at it like this, yes? Is that an easy question? No. You're like, dude, I just learned that freaking symbol. All right, so let's analyze this shit. Let's break this down. What does A divide M mean?
A times something equals N.
Yeah, so say A times X equals M. I like the enthusiasm. A times something. I like it. You're thinking ahead. So what about the other dude? So we know this, which means this. We know this, which means what?
A times something equals N?
Yes?
Is that the same thing?
Stay with me, stay with me. Stay with me. And what is it that I want to analyze? I want to look at this, yes? What is M plus N? Based on what we just wrote down. What is M? AX. What is N? AY. Does A divide this? Right? By definition, it divides that bad boy. So 3 goes into 6. 3 goes into 12. Does 3 go into 6 times 12? 72. Of course it does. It has to. That's all that says. I love it. Okay. Does that make any sense? Here's another way to look at it. So 3 divides 12, yes? And let's do it. Let's say 3 divides 3 and 3 divides 6, right? So 3 divides 3, so I can put 3 dots. Okay. 3 divides 6. So 3 divides 3, so this will be 1. That's 3 divided by 3 is 1. I need 1 row to put 3, right? 3 does not divide 4 because I have an extra 1 out. Let me make sure everybody understands the pictures I'm trying to make. This shows you that 3 doesn't, in fact, there's a symbol for does not divide. There's a symbol for it, because does 3 divide 4?
No.
Shit, no. So let's do this. Oh, that's amazing. That's creative, math people. Just put a line through the line and it means does not divide. So 3 does not divide 4 because there would be 1 extra. You can't put 4 dots into a group of 3 evenly. You can't. But I can put 3 dots in a group of 3. I can put 6 dots in a group of 3, 2 groups of 3. So that's why 6 divided by 3. See, this is all groundbreaking. I know it's groundbreaking. So watch this. What about 3? All right, so this. What about 3? Does that go into 9? Yes, because I can put the 3 3s, and I can put the 2 3s, and there we go. There's 3 divides 3. There's 3 divides 6. And of course 3 divides 9 because I got 3 groups of 3s. So it goes in 3 times. Okay, maybe. There's a visualization of that idea. Okay. Okay.
I kind of get the idea now.
Good. I think this is less, I mean, I think these are ideas you're used to. You probably haven't seen them written this way. I really doubt that people have seen this symbol before this way, to be a divisor. How often have you heard the word divide? You've seen it? Cool, I like it. You've seen it?
And like dividend and stuff?
Yeah. Okay. I like it. I get so excited when I'm like, oh, I thought I was the only one. Okay, so, okay. This chapter, this section, section 5.1, brings back stuff that I've told you before. So we went over kind of quickly, and in this section, it's got all of them. The division process for 2. How can you tell if something's divisible by 2? If it's even. Ooh. What about divisible by 3? We just talked about that, right? If all the digits add to be a multiple of 3. Cool. What about 4? Does anyone remember the one for 4? No? It has to be like doubly even or something, it's kind of weird. Listen, guys, I really want this to make all the sense in the world. Doesn't 4 go into 100?
Yes.
Therefore, 4 goes into, I've erased, 100 plus any multiple of 4, yes? If it goes into 100, it goes into 104. If it goes into 100, it goes into 200.
Like leap year.
Yeah, sure. Yeah, whatever. Okay, whatever makes sense. Or presidential election years. All right. Since 4 goes into 100, I only have to look at the last two numbers.
Yeah.
If the number, so does 4 go into this number?
Yes.
Yes, okay. Because 4 goes into 12. Does 4 go into this number?
Yes.
Yes! Because 12. Does 4 go into this number though?
No.
Shit, no, because the last two numbers are 27. 4 does not go into 27. Okay, maybe. I really want this to make sense. 4 goes into 100 how many times? 25. So 4 goes into 200 how many times? 50, right? Does it make sense? 25 4s to make 100. So therefore, twice as many 4s, 50 to make 200. So 4 goes into this shit, blah, 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 times, right? Every 100 is 25 4s, right? So 200 is 50. 300 would be 75 4s, yes? I'm sorry? Yeah, I kind of changed the number, didn't I? Let's make this like that.
Oh.
So, it'll be this many hundreds that 4 goes into, and then of course it also goes into 12. So that's why it goes into the whole thing. Okay, enough for 4. 5 is easy, right? 5 is easy. 5 or 0. What about 6? Now you can do like you're trying to do, right? What's 6 is 2 times 3. So how do I tell if something's divisible by 6? If it matches, if it's even, and all the numbers add up to be divisible by 3. Because then it's divisible by 2 and 3, therefore it's frickin' divisible by 6, isn't it? Let that make sense.
No. It didn't.
Damn it.
Can you restart that?
Yeah.
From the beginning?
So if a number is even, what do you got, Jeff? Hold on. 5, 3. Try to make this a specific even. Okay, here we go. If a number's even, my poor marker. Give my marker a break here. Is that better?
Yeah.
Okay. If a number is even, it's divisible by 2. If it also is divisible by 3, wouldn't it be divisible by 6?
Yes.
Okay. How do I check to see if this is divisible by 3? 4 plus 2 is 6. It's divisible by 3. So 3 divides this, 2 divides this, therefore 6 divides this.
Yes.
So how are you divisible by 6? You got to meet the requirements for 2, and you got to meet the requirements for 3. You meet the requirements for 6. Chickens and cats.
Does that say 3 divided by 402?
No. What's this say?
3, 1, 4, 0, 2?
3 is a divisor of
Oh,
4
divisor. Yeah, that's what I was asking. Dividing.
No, but this is not 3 divided by 402. This is 3 is a divisor. Yes.
Could you say like 3 goes into 402
Yes.
evenly?
Yes,
Would that
I
be
love
another way of
it.
saying
So that's the longer way to say
even?
divisor, is goes into evenly. I love it. Okay, I like it. All right, so. Okay, yeah, I like it. We got one more thing to do, and then we'll call it a day. Let me see if I can get everybody a little awake. If I say that phrase, maybe you'll rejoin me. No, a little bit? All right, watch it. So what we're going to do is we're going to prove the divisibility rule for 9. Because Because if we can prove the divisibility rule for 9, that basically proves the rule for 3 also. Alright, so this is gonna get really interesting. So, here's the reason this is gonna get weird. The proof of these would be weird. The proof, what was the divisibility rule from 9? It's the same as 3 basically.
They can add up, if they all have the number. All the digits add up to 9.
If all the digits add up to a multiple of 9.
Oh, okay.
Yeah,
That's-
okay. So, you guys are not that familiar with proofs. I know, because you just have never really had to do a lot of proofs, maybe except for geometry. You guys remember geometry? You had angle, side, angle, and all that kind of shit? Angle, side, side, which is the bad one. Normally it's side, side, angle, because in high school people try to stay away from the word ass. But I like the ass because that's the one that's mean. So, if I have a 3-digit number, is everybody cool? Now this is going to be weird. This is exceptionally strange because this does not mean A times B times C. If I make A4, B7, and C3, that's the number 473. Is everybody with me? That is the most general 3-digit number. Let's write this in a little bit different way. So again, if A is 4, B is 7, C is 3, this is the number 473. Can somebody, what is that? And again, let's go back in time. What the shit does that 4 mean? 4 whats?
What? 400.
400s. And that's 7
7,
10s, and that's 3 1s, right? So 3. So isn't this 4? Yeah, all right, let's keep it like that. Screw it. All right. This is kind of melding two things together. We looked at that before. We know our base. Base 10, Jeff. All right. So what does this number look like if I break it out? A times 100 plus 10
C times
plus C. So let me write this a little bit better. Isn't this 100A plus 10B plus C? Yes? How do you compose a 3-digit number? Well, you pick the first digit, which is the hundreds place, so you'd actually multiply by 100, and blah, blah, blah. That's all it says. Okay. Now, you gotta go. Now, this is neat. I'm trying to prove the rule for 9. So let me make some 9s show up and see what happens. In fact, what is the rule for 9? That if I add up all the digits, it's divisible by 9, right? So what's add up all the digits look like? Ignore this for a second. Here's the number, ABC. What would add up all the digits here be? What would you get? 14. Is that divisible by 9? No, you suck. So what would it look like here? My number is A100, B10C. What do you get when you add up all the digits? You could do it. What'd you do here exactly? Tell me exactly what you did to get the sum of the digits. 4 plus 7. Okay, what do you get when you add up all the digits?
ABC.
No.
100.
Stop looking at this. You're not multiplying them, you're adding them. So wouldn't it just be, right? Okay. Okay. I'm sorry, I didn't hear you. All right. So, now watch this. Let's see if you guys see why this makes sense. I'm going to rewrite this like this. Okay, that's the first step there.
I do that?
Isn't that true so far?
I don't know where you got the 99 from.
Well, 100A, isn't that 99 A's plus 1A?
Yes.
Yes. Why is that kind of nice? Isn't 99 freaking divisible by 9? So it looks like maybe I'm going on the right track. I love you guys so much. And then 10B, guess what I'm going to do with it?
9 plus B.
So isn't this 99A plus 9B plus A plus B plus C? So if A plus B plus C is a multiple of 9, okay, stay with me, we're almost there, right? What's the rule? If the sum of the digits, A plus B plus C, is a multiple of 9, the sum of the digits, a plus b plus c, if that's a multiple of 9.
These are multiples of 9, correct?
Say again, say.
So you're just assuming that A, B, C, or A plus B.
Yes, exactly, because that's the given. If they are a multiple of 9. If they aren't, screw them. They're not going to work. If they are a multiple of 9, why does that mean the whole thing is divisible by 9? That's what we're proving. So I know this is actually 9 times something. So isn't the whole damn thing divisible by 9? Yes. Could you have lived your whole life and never seen that and just
Yes.
done the rule? Too damn bad. You took the wrong class.
Oh, no.
Because I'm going to show you why shit works. Okay. Or some of it anyway. Alright, that's enough. That's enough. That's plenty. We have done quite a bit. So that's section 5.1.
Oh, that's crazy.
Wasn't that fun?
No.
So, what do you guys think I'm going to have for you this Thursday?
5.2 maybe?
No. What am I going to have for you? Practice test.
Correct?
Oh.
Wait, but next week is what, but,
The test is on Thursday.
wait, this Thursday, next Thursday?
Next Thursday.
Oh, because we haven't even done 5.2 yet.
That's why we have one more day, and then next Tuesday is review day.
Oh, okay.
I like it.
Oh, shit.
Okay, yes. Second, sorry. Alright, let me write up here. So, next Thursday is the test. So I'm gonna give out a practice test this Thursday. Next Tuesday is review day. Does that help if I scribble shit on the board?
No, because I'm gonna be here Thursday, so do you have the practice with
Oh, no, I don't.
I got an Amazon. Get them anywhere.
Turn the dude off.
So YouTube, shout out to my channel.